Okay. So class, we're going to talk about adaptive immunity. So last time we talked about innate or non-specific immunity. This time, um, we have we have the special cells, and basically they uh, they help remember diseases, and it is through this function of our body that we are able to create vaccines. So before the creation of the vaccines, you have lots of diseases you have lots of plagues, lots of pandemics that have killed a lot of people. So here, this picture shows you a chamber for polio victims. So polio, common siya dati. In fact, there was a boxing si Peñalosa who had polio. And during my time, siyempre matanda na ako, may mga kilala ako na nagka-polio. Yung pag, ang usually nakita ko na nagka-polio yung mga paa nila hindi na develop, yung mga legs nila hindi na develop fully. So, di nakakalakad. So, common ito dati. And yung pinaka uh, malalang or serious consequence ito yung paralysis. So, dati merong iron lung ward. So, dito napabuhay yung mga polio victims or besides sa polio. Pero now, because of our utilization of the adaptive immunity, so we use that the type of memory or the type of specificity na nandun sa immune system natin to create substances that will help us fight these diseases. Okay, so let's look at let's have an overview of what adaptive immunity. So another term is acquired. So pag sinabi mong adaptive immunity, in contrast dun sa innate or nandun talaga, so hindi kailangan ng any trigger para mag-function siya, nandun siya sa body natin. Pero itong adaptive immunity, it is defined by two characteristics, no? So, natatandaan niya, quote unquote, or may memory, pero hindi naman in terms of memory na what we define as memory na ginagamit ng brain. So, basta parang na-program, pag may sakit ka, na-program sa body na itong disease ay ay na, na, kumbaga yung body mo ay nakasakit na sa ganung disease. So, parang quote-unquote memory nilang tawag natin. So, also, we also have specificity. So, pag sinabi mong specificity, it targets specific pathogens. So, yung mismong sakit na nagkaroon ka. Tapos yun, naalala or na-program sa body na or yung nakasal ka ng ganito. So, mag-react yung body mo in a certain way. So, memory refers to the ability to quickly respond to the pathogen. So, in that sense, yun yung quote-unquote memory na pinag-usapan natin. So, pag sa unang sakit natin, so sa first exposure natin, mabagal yung natin, response ng body. Unang sa, the first time na-encounter natin yung isang virus, bacteria, basta may pathogen na na-encounter, mabagal yung response ng immune system. No? And if there's a secondary exposure, mas mabilis mag-respond yung body to defend the body against the attack. So, nakita mo dito sa graph, so sa primary and secondary response, so sa unang curve, makikita mo na mabagal yung response pag primary immune response. Pero pag nagkaroon ng secondary exposure, mas mabilis yung response ng body. Nag-produce ng mga chemicals like antibodies to fight these diseases. So basically, pinag-usapan na natin yung mga white blood cells. Dito sa adaptive immunity, we're going to concentrate on the B lymphocytes or the B cells, and the T lymphocytes are the T cells. Okay, so let's go to the next slide. Okay, so yung mga pathogens natin or those microorganisms that cause disease or even virus, they have certain structures in their body. Okay? So because of these structures, the reactive immune system natin, we sometimes make antibodies. Okay, so yung antibody generating, so kaya in short, antigen. Okay, so this antigen is macromolecule, maybe a protein or a carbohydrate that reacts with components of the immune system. So it's sabihin, let's make it general kasi even our own cells in our body can be attacked by our own immune system. No? So in general, so kahit hindi foreign yan, we can have our own cells wherein we create an immune response. So in general, ginagamit natin yung antigen. So it has a given antigen may contain several motifs that are recognized by immune cells. So yan, yung mga structures na yon, these antigen na yon, we call that specific structures epitopes. Okay? So yan. So yung regions na antigens na yan, we call epitopes. Maraming epitopes na makikita mo sa antigen. So we form antibodies to fight those to mark those antigens, and with the help of other components in the immune system, we destroy or suppress these antigens. Okay, so first, ano ba yung antibody? So you might be you hear this all the time, antibody. So ang antibody, basically, ito ay gawa sa proteins na may konting carbohydrate component. So in biochemistry, we call that glycoproteins. So present yan sa blood and tissue fluids. So ito yung structure niya, no? So you have a variable region na ito yung kumakabit sa antigen, and then you have the constant region. Okay? So yung Y shape na yan is also called the FAD region, which is called the fragment of antigen binding. So dyan na nagbabind yung antigen natin. Yung ano natin, yung antibody sa antigen. Okay? And then you have the heavy chain region, or the constant region. We call that the fragment of crystallization region, or FC region. Okay? So simplify lang yung structure niya. We can see this ribbon diagram of the antibody. In terms of molecules, ay hindi ganyan itsura ng mga atoms. Sinimplify lang yan in terms of the ribbon diagram para makita mo yung mga secondary structures, tertiary structures dun sa protein. Pero mas complex pa dyan. Okay? So ito yung standard structure ng antibody niya, IgG. So maraming klaseng antibodies. So we'll discuss them. So another term for the antibody is called immunoglobulin. Okay. So we have 5 classes of antibodies. So we call it the IgG, the IgM, the IgA, IgD, and the IgE. Okay. So dito muna tayo sa IgG. So ito yung pinaka-abundant antibody sa human body. So around 80% nandun sa cell natin. So dahil sa structure niya, nakaka-penetrate sa mga tissue spaces, and kaya niya mag-cross ng placental barrier. Ano ibig sabihin nun? Ibig sabihin, yung antibodies ng nanay, pwede niya mabigay sa child niya, di pa na-born na baby. So, sa fetus, yung antibodies ng mother, papasok din sa fetus. Okay? So, yun. So it gives passive immunity to the developing fetus during pregnancy. At saka very versatile yung IgG in terms of the role sa body's defense laban sa mga sakit. Okay, so yan. Yung number of binding sites, may dalawa ka. Punta ulit. It's this complement. So, yung FC nagbabind sa mga phagocytes. So, pag kinakain, di ba, once na-mark yung antigen, di ba, pumapalibot yung antibody. So, yung phagocyte, yung macrophage, pwedeng kumabit din sa kabilang dulo, which is the FC. So, dyan, ano yung function niya? Neutralization. That's right. Neutralization, agglutination, complement activation. So, yung complement cascade na pinag-usapan natin sa innate immunity. Opsonization, yung kakasabi ko lang, di ba, kinakabitan niya yung pathogen, di ba? Ng FAB region, isang kabilang region sa baba, kumakabit din sa macrophage. So, nagkakaroon ng opsonization. Namamarkahan for uh, phagocytosis. Okay? So we have also the antibody dependent cell mediated cytotoxicity, which we'll talk in a while. And then second, we have the IgM. So yung IgM na produce siya dun sa monomeric membrane bound form at saka siya yung nagsiserve as antigen binding receptor sa B cells. So makikita mo siya sa B cells. So yung secreted form ng IgM, so kita mo lima yung structures na, no? Parang limang IgG. Okay? So bawat site na yan, pwede kapitan na sa antigen, sa once na kumabit sa antigen, yan, may 10 sites ka na pwede kapitan. So, konti na yung percentage niya sa body, 6%. It doesn't cross the central barrier. And yung sa complement cascade, nag-type siya, which is the complement cascade. And then, it also is involved in the realization, agglutination, and complement activation. So yung form niya na kabit sa B cell receptor or sa mismong B cell naka-split. Okay, so punta na tayo dito sa IgA. So IgA, so around 13% yan ng antibody sa serum, sa blood natin. So it's the most common and abundant antibody class found in mucus. Sa mucus natin, yung IgA. Nakita rin siya sa saliva, sa luha, or tears, sa breast milk. Okay? So yung structure na, no, dalawang form, dalawa yung pwede kabitan bawat side, so apat all in all. Okay? So, yeah, tawag dyan dimer, no? Magkabaliktad. Para mirror image yung kabilang form. So, dimeric form with two monomers joined by this protein structure. So, yan yung secretory component. So, ang important niya, ang function niya, it neutralizes and traps the pathogens in the mucus. Okay? So, yan yung pinaka-importante yung role. Ito namang IgD. So, it's a membrane-bound monomer and it's also found in the surface of the B cells. Okay? So, nagiging antigen binding receptor siya. So, hindi naman siya secreted by B cells. And konti lang makita sa serum. Pero yan, basically nakakabit lang sa B cell yan. So, trace amounts na makikita mo, most likely that come from degraded B cells. And then you have the IgE. So, ayun structure na IgE. So, pareho siya na IgD na dalawa lang pwedeng kabitan. So, it's the least abundant antibody in the serum. So, it's secreted as a monomer, as hiwalay na ganyan. So, restricted lang sa mga anti-parasitic defenses, sa mga nematodes, other parasites, mga eukaryotes. So, itong region na ito sa baba, yung FC region, nagbabind sa mga basophils and mast cells. Okay. Tapos yung FAB region, ito yung nag-interact sa specific antigen epitopes. So yun, mag-release ng pro-inflammatory mediators. So kaya nag-activate yung mga mast cells and basophils in defense of the parasites. Okay. So kita nyo paano siya nag-bind. So hanapin yung spike sa virus. This is spike sa virus nag-bind. So yung diphtheria-toxin, nag-bind din sa structure ng diphtheria-toxin. Kahit sa flagella ng isang bacteria, nag-bind din siya. So neutralization involves the binding of specific antibodies to antigen found on bacteria, viruses, and toxins and prevent them from attaching to target cells. Okay? So wala na itong virus na yung spikes na dyan kakabit sa cells para i-hijack yung cells para mag-create ng more virus. So once na masurround ko ng antibodies, hindi na magagawa ng virus yun. Okay, so ito yung sinasabi natin opsonization, no? So parang kino-coat niya yung pathogen with the antibodies. So once na na-coat yan, so kita mo yung mga antibodies na naka-surround sa pathogen. Yung FAB, yung nakakabit sa epitome sa mismong pathogen. Tapos yung FC region, yun yung kakabit sa macrophage or phagocytic cell. So, yun, na-involve na yung pathogen. So, yun ang tawag na opsonization. Okay? So, malaking bagay yung opsonization para ma-digest yung mga pathogens. And also, we have also agglutination, no? So, nakita natin yung test for diseases, no? So, nakita natin, na-discuss natin before, yung presence of virus. So, yung agglutination, binabind niya yung mga different bacteria or different cells. So, antibodies, especially IgM antibodies, agglutinate bacteria by binding to epitopes one, two or more bacteria simultaneously. So, pinagsasama niya yan para mas madaling ma ano ma ma-attack ng mga phagocytic cells para isang kumpulan na lang. At saka mas maano siya na-degrade ng mga kidneys at saka spleen, ma-filter siya sa blood. Yun nga. So, ma-atake siya ng mga phagocytes for ingestion. Tapos makita mo yung pentameric structure ng IgM. Okay. So, pag malaki masyado, paano kung malaki masyado ang isang pathogen? Okay, so dito pumapasok yung antibody-dependent cell-mediated cytotoxicity or ADCC. Okay? So, na-enhance din yung pagpatay ng pathogen kung malaki masyado. So, gagamit siya ng NK or natural killer cells. Although it can involve macrophages and eosinophils. Okay? So, ang mangyayari dyan, you have the FAB region sa antibody, nakakabit sa antigen. So, yung FC receptors, ayan, yung violet. No? So, yung FC receptors, yung FC region na yan, magbabind sa, yung FC receptor pala nung natural killer cell, magbabind sa FC region ng antibody mo. Okay? So, lalapit na yung natural killer cell. So, pag lumapit na yung natural killer cell, makaka-release na siya ng mga cytotoxins, no? So, yung example niyan, yung perforin. Yung perforin ay protein na yan na gagawa ng butas dun sa cell membrane. Tapos yung granzyme, ito yung program ng yung cell para sa mag-self-destruct. Okay? Okay. So, yun. In discussing this, no, we encountered dito sa innate immunity natin, discuss natin yung MHC plus 1. Okay, so, ito yung major histocompatibility complex molecules. So, pag normal cell, hindi cancerous or hindi infected, yung MHC plus 1, yan, makikita mo sa lahat ng normal cells. Okay? So basically, yung MHC or major histocompatibility complex, mga collection yan ng genes na code for MHC molecules that are found in all nucleated cells of the body. So, wala lang yan ang red blood cells. Okay? So, kasi yung red blood cells kasi, yung mature red blood cells, walang nucleus. So, sila lang yung walang MHC. Okay? So, there are two classes, no? MH1 and MHC1 and MHC2. So, as I've said, yung MHC1, natatagpuan sa lahat ng nucleated cells. So, yung red blood cells, walang nucleus pag mature na. So they present normal self-antigens as well as abnormal or non-self-antigens to effector T cells involved in cellular immunity. So pag na-present yan, parang idea na normal na ako. So hindi yan atakin basta-basta ng natural killer cells. Itong MHC class 2 or MHC2, these molecules are only found on macrophages, dendritic cells, and B cells. So, dito, yung itong MHC naman, na MHC2, pinapresent abnormal or non-self pathogens for activation ng T cells. Okay? So, yung gusto na yan, so gawa yan ulit sa proteins, so glycoprotein pa rin yan, naka-oscillate sa cell membrane. Okay, so di ba, if I remember, hindi ko pa yata napakita sa inyo. So, pag ang mga phagocytic cells nag-destroy ng pathogen, no? So yung structure niya, Diba itong dendritic cell, no? In-engulf niya itong bacterium, tapos yung mga structures niya, ipapakita niya sa ibang cells, no? So, yun yung kaya tinatawag itong antigen-presenting cells. So, papakita niya, kumbaga, kumuha siya ng CCTV picture para sabihin sa ibang mga pulis na hey, magnanakaw. Okay. So, yun yung ano ko. So, parang analogy ko. So, basically, may structure dun sa bacteria na nasa labas niya para ipakita sa mga ibang mga immune cells, yung kasama yung T cells, at saka especially yung T cells. Okay? So, uh, lysosomes fuse with the phagosome to create the phagolysosome, where antimicrobial chemicals and enzymes to create the bacterial cell. So yun, process bacterial antigens, and the most antigenic epitopes are selected and presented on the cell surface. So nasa labas siya, no? In conjunction with the MHC2 molecules. So again, nangyari sa step 1, yung bacterium na engulf, so na digest, tapos yung structures niya, shown by the red, so antigen. So, kakabit dun sa, ano mo, sa MHC molecules mo. So, nasa labas siya ng dendritic cell. So, yan yung immunodominant epitopes are presented on the cell surface. Okay. So, yan yung later on, this dendritic cell will go to a nearby lymph node para present sa T cell. Tapos ma-activate niya yung T cell kasi nakita niya yung piece ng pathogen. Okay, so let's talk about the T cell. So yung may two types of ano tayo, no? Two types of adaptive immunity, no? So meron tayong humoral at saka meron tayong cellular immunity. Okay, so itong T cells involved this cellular immunity. So yung structure na T cell natin. So this is responsible for the cell-mediated immune response. So the spike-like membrane structure increases the surface area, allowing for greater interaction of other cell types and their signals. So kita mo yung structures na yan yung parang magko-communicate sa ibang cells. Okay, so let's look at it. So, saan ba yung production niya? Dito nandun yung production niya sa red bone marrow. So, it's found in the femur or the thigh bone. Meron din sa mga flat bones sa body. So, kasama rin yung skeletal system sa paggawa ng blood. So, involved bones sa paggawa ng blood natin. So, dyan ginagawa yung erythrocytes, leukocytes, and platelets. Okay, kaya tinatawag itong T cell. So, dahil sa thymus. So, nagmamature siya sa thymus. Nagkakaroon ng differentiation. So, iba-iba yung path ng mga white blood cells. So, dito yung T cells dito sa thymus na na-develop and na-differentiate. Okay, so what are the classes of T cells? So, itong helper T cells, ito yung parang general, no? So, siya yung the brain kumbaga the brain behind the immune system na paano atakihin yung isang antigen. So, meron tayong tinatawag na surface molecules sa CD4. Okay. So, tandaan yan kasi may CD8. So, yung CD4, yung interaction niya is when it is presented antigens associated with MHC2. So, 4 at saka 2. Tandaan nyo yan, 4 at saka 2. Interact yung CD4 sa 2. So, isipin nyo lang 4 times 2, 8. Okay? So, anong function ito? Orchestral, humoral, and cellular immunity. So, involved siya sa activation ng mga macrophages at saka natural killer cells. Okay? And then you have the regulatory T cells. So, nasa surface na CD4. So, APCs presenting antigens associated with MHC2 ang nag-activate sa kanya. So, yan, CD4 at saka 2. MHC2. So, itong regulatory T cells, more on, parang inaano niya yung immune system na wag atakihin yung sariling cell. Okay? So, involving peripheral tolerance and prevention of autoimmune responses. So, ayaw mong atakihin ng immune system ng sarili mong cells. Di ba? Kasi syempre, kung hindi mo di-distinguish ang immune system niya, dahil lahat ng cells natin papatayin. Di ba? So, yan. Yan yung function ng regulatory T cells. Okay? And then you have the cytotoxic T cells. Okay, so tandaan niyo yung surface CD molecule, CD8. So APCs are infected nucleated cells presenting antigens associated with MHC1. So, tandaan niyo yung CD8 nag-interact sa MHC1. 8 times 1, basta 8 pa rin. So, para matandaan niyo, basta 4 times 2, 8. 4 times 2, 8. 8 times 1, 8. Okay, so APCs are infected nucleated cells presenting antigens associated with MHC1 ang pag-activate ng cytotoxic T cell. So, yung nakita nyo kanina sa microscope, yung mga surface molecules na naka-houseplant, nag-interaction din sa mga APCs like yung dendritic cell. So, yung cytotoxic, from the word cyto, cell, toxic, so papatay niyo yung cell. It destroys cells infected with the intracellular pathogen. So, we call that receptor, we call that TCR or the T cell receptor. So, the T cell receptor spans the cytoplasmic membrane, so almost nakausli siya, and projects binding regions into the extracellular space to bind processed antigen associated with MHC1 or MHC2 molecules. Okay, so variable region pa rin, you have a constant region. So parang sa antibodies. Okay, so paano ba na-activate ang helper T cells, no? So pag sinabing naive, hindi pa siya na-activate. So inactivated siya. No? So like I said, so yung dendritic cell, no? Kinain niya isang, let's say, virus. Tapos, yung structures ng virus, nasa labas niya. So APC, represent sa ibang mga police. Nakita niyo ba to? So basically yan, yun yung APC niya. Kung magka-travel siya sa lymph node, tapos nga kung saan yung mga T cells. So yung naive or inactivated helper T cell, mag-vault in sila. So let's vault in. So once na nag-vault in siya, itong naive helper T cells, magiging activated helper T cells. So ma-recognize yung structure. So specific siya dun sa structure ng ng antigen. Okay, so tandaan mo yung CD4 kumabit din sa MHC class 2. Tapos yung antigen extracted from the pathogen, hindi ma-recognize ng activated helper T cells. So from that, yung activated helper T cell, magkakaroon ng tinatawag na clonal proliferation and differentiation. So mag-form ka ng mga helper T cell 1, helper T cell 2, at saka memory helper T cell. Okay. So yung TH1, ito mga subtypes ng helper T cells. So TH1, stimulate yung cytotoxic T cells and produce memory cytotoxic T cells. Okay, so it also stimulates macrophages and neutrophils for more effective intracellular killing of pathogens. No? Kaya para siyang general. So paano natin atakin to? So with the innate immune system, atakin nila yung mga unwanted foreign pathogens. So yun, it also stimulates natural killer cells to kill more effectively. Okay, and then you have H2 cells. So this stimulate B cell activation. So ito yung involved sa B cell. So tandaan niyo yung B cell ay involved sa humoral or yung mga pathogens na nasa labas ng cell or extracellular. Okay? So pag intracellular, you have the helper T cells involved. Pag extracellular, mga B cells ang involved. Okay? So it stimulates B cell activation and differentiation into plasma cells. So itong plasma cells, ito yung napoproduce ng antibodies. Okay? So yung B cell, in a way, they produce the antibodies. So they produce the antibodies and also produce memory B cells. So they direct antibody class switching in B cells also. TH17 cells, so this stimulates immunity to specific infections such as chronic mucocutaneous infections. And then you have also memory helper T cells. So from the word memory, so it remembers a specific pathogen, and this helps a strong rapid secondary response upon re-exposure. Okay. So ito yung cytotoxic T cell in action. So its only role, pinapatay niya yung cell. So this figure illustrates the activation of the naive or unactivated cytotoxic T cell by an antigen presenting MHC1 molecule. Okay, so again, yung MHC plus 1 or MHC1 mag-activate ng CD8. Okay? So once activated, the cytotoxic T cell, mag-release siya ng mga chemicals na sinabi ko kanina. So yung perforins, taga-butas. Tapos yung granzyme, ito yung nag-trigger ng self-destruction ng cell or apoptosis. Okay? So controlled cell death. So not every time na maganda yung reaction ng immune system, no? So meron tayong tinatawag na super antigens, and pag may super antigen ka, hindi dapat nire-recognize ng T-cell yung structure ng yung epitope na yun, hindi dapat ma-recognize ng T-cell. Pero dahil sa presence ng super antigen, na activate pa rin. So ang problema nito, trigger ng release ng mga cytokines. Kaya this is dangerous. Okay? So yung macrophage nag-present ng super antigen that is not recognized by the TCR, yung receptor mismo, no, of the T-cell. Pero dahil sa super antigen, nag-bridge siya, nag-bind yung MHC2 at saka PCR. So, nagkaroon ng uncontrolled activation of the T-cell. So, ito yung tinatawag na cytokine storm, no? Pag nag-react yung immune system ng sobrang zealously na mag-release ng maraming cytokines. So, ito yung minsan cause of death ng sa COVID, no? Nag-react masyado yung immune system dahil dito sa mga super antigens. Okay, and then we'll talk about the lymphocytes. So, ganyan na-counsel yung sa B-cell mo. So, B-cell receptors or BCR, these are embedded in the membrane of the B cells. So, the variable regions of all the receptors of single cell bind the same specific antigen. Okay, so like parang antibody structure pero nakakabit sa B cell. So kahit wala yung T cell, pwede ma-activate yung B cell mo. No? So ito yung tinatawag na T cell independent activation. Okay? Sorry. So sa T-independent antigen, T-independent T cell independent activation, yung mga antigens mo na T-independent, so hindi na-trigger ng T cells. They have repeated epitopes, no? So dahil dun, mayroong mga yung B cell mo, nagkakaroon ng kumbaga maraming receptors na baband. Okay? So they have repeated epitopes that induce B cell recognition. So dahil dun sa maraming nakabind na induce yung B cell recognition without involvement from T cells. So yan yung first trigger. Tapos yung second signal, meron kang interaction ng TLRs with pathogen associated molecular patterns. So, required din yun sa activation ng B cells. So, once activated, so magkakaroon ng proliferation and differentiation ng mga B cells. And eventually, they will form the antibodies. Yung magiging plasma cells na siya, magpo-form siya ng antibodies. Okay? So, yeah, yun ito yung so mas complicated siya kaysa T-cell dependent. So, in T-cell dependent activation of B cells, so the B cell recognizes and internalizes an antigen. Okay, so internalize antigen, and then and presents it to a helper T cell. Papakita niya sa T cell. So this is specific to the same antigen, and then the helper T cell interacts with the antigen presented by the B cell, which activates the T cell. Okay, so yeah, CD4 again, and MH4. So i-activate itong B cell, activating B cell with the help of these cytokines. So, sorry. Basically, yung B cell, yung ma-activate, mag-activate dun sa T cell para mag-release ng cytokines. and then subsequently ma-activate yung B cells. So parang ano, again, so once na sumabit yung CD4 at MHC2, yung ano mo, yung B cell mo ma-activate mo. Then activate siya, mag-release siya ng mga cytokines which will activate the B cells. So magkakaroon ng proliferation and differentiation into plasma cells and other B cells. Okay, so kita mo yung mga unang mga antibodies na respond. Maraming napoproduce mo na IgG sa secondary response or secondary exposure. Marami agad na IgG na antibodies na produce. Kaya sa COVID, yung mga early ginagamit nilang panglaban sa COVID, yung serum or yung dugo or tinanggalan mo ng mga blood cell, ng red blood cells. Kinuha mo yan, pwede mo, may antibodies siya, pwede mong panlaban. Kumbaga, emergency fight against COVID. So, lalo na sa malalaman. Okay, let's talk about vaccines. So, ito, because of our understanding, hindi naman natin actually na-understand agad, pero we discovered that there are certain diseases that help fight yung mga deadly diseases like smallpox. So, without understanding din sa without understanding our immune system, they discovered, di ba si Jenner, they discovered na yung cowpox. Pwede niyang deliberately ihawa sa mga tao para hindi na magkaroon ng smallpox. Kasi yung smallpox, very deadly disease yun. And cowpox is not that deadly. So, once na nagkaroon ng cowpox, hindi na magkakaroon ng smallpox yung mga tao. Okay, kaya tinawag yan na vaccination dahil baka, siba, cowpox. So, yung Latin word, yun ang ginamit mo sa term na vaccination. Okay, so, yun. So, importante yan. Importante yung, even without understanding yung immune system natin, nagamit natin yung knowledge niya. Diba? So, even during ancient Rome, times, sa ancient Rome, may mga historians na nakakapansin na yung mga nagkasakit na gumaling, hindi na sila uli nagkakasakit ng same disease even though they're in contact with those who are sick. So, hindi nila naintindihan nun, pero at least may concept sila na merong immunity in a way. Okay? So, there are two forms of acquisition of immunity. So, meron tayong yung natural acquired at saka artificially acquired. So, naturally acquired kung passive, immunity acquired from antibodies passed from the breast milk or through the placenta. So, binibigay ng mother yung antibodies niya ginagamit ng newborn baby. Okay? It's a natural acquired. Siyempre, kung magkasakit ka, natural na magkakaroon ka ng antibodies. Okay? So, kayo, hindi nyo pa alam, pero marami na kayong antibodies yan sa laban sa dengue, even though hindi pa kayo nalulubhang nagkasakit ng dengue, meron na kayong antibodies yan kung madalas kayo makagat ng lamok. Hindi lang kayo na hospital. Okay, so pwede mangyari. You have gained immunity through exposure or illness. Okay, so yan, yung dalawang ways na naturally acquired ng immunity. Yung sa second, yung artificially acquired, so explain ko kanina, di ba, yung sa COVID, yung first na panggamot nila sa COVID, yung serum ng may nagkasakit na. Kasi yung serum ng may sakit, nagkasakit na, sila yung may antibodies. And yun yung panlaban din sa COVID. So, passive yun. So, pag wala ng serum, wala ka na uling panlaban. Yung active, yun yung paggagamit ng vaccines. No? So, we deliberately parang i-trigger natin yung immune system natin to act in such a way na mag-produce ng antibodies or na-remember na ito, nagkasakit na ikaw kahit hindi pa. So yan yung function ng vaccine. So dati pa, even before Dr. Jenner, marami ng historical records na kahit yung mga Japanese gumamit ng similar technique ni Jenner to prevent the spread of smallpox. Okay? So yan. So yan yung cowpox. Tapos may milkmaid sa, kasi sila yung, sa, nagkasakit ng cowpox, no? So yan, kaya tinawag na vaccine. Okay, so let's talk about the different classes ng vaccine. So, meron kang live attenuated. So, ito yung buhay na virus, pero na-weaken. Kumbaga, dapat hindi siya makakos ng disease. No? So, weakened strain of whole pathogen. So, hindi siya mag-perform ng serious disease. So, advantages niya, it produces cellular and humoral immunity. And this has long-lasting immunity and transmit yung transmission din to contacts, no? So yung virus na yon na weakened, pwede mong i-pass on to other contacts, and they will also produce antibodies without being seriously sick. Ang disadvantage nito kasi nga virus to or pathogen to, kailangan mo yung cold storage. So, yun ang delikado. Tsaka, nangyari na to sa polio. Kasi I think polio, ito nangyari. Nagamit, instead of a weakened version, ang na-inject nila sa mga patients or mga nagpapavaccine ay yung unweakened form or yung mismong sakit. So, very controversial yan. Kaya marami rin nag-discuss ng vaccination process kasi hindi naman perfect yung yung paggamit ng vaccine. So, kaya nga nagkaroon ng phase 1, phase 2, phase 3 trials para to make sure na hindi magkakaroon ng adverse effects ang vaccine. So, kaya mahaba usually ang process ng pag-approve. And dahil yung sa COVID-19 naman kasi, very infectious. So, parang nagbalanse na lang sila na ano bang mas importante. Do we save lives by producing yung vaccine kahit hindi pa kumbaga, hindi tayo dadaan din sa mahabang process. So yun, parang ethics na yung pinag-usapan. Mas maraming tao masasave mo by producing the vaccine in a faster way. So, yeah, ethics na lang yun. Policies na yan ng government. Anyway, an example ng mga vaccine, you have chickenpox, German measles, yung MMR, yan ay live attenuated. Tuberculosis, typhoid fever, yellow fever. Inactivated naman yung second class. Na, bali, pinatay mo yung pathogen. So, ang meron mo lang meron pang mga antigens. Pero yung mismong pathogen, hindi na magre-reproduce sa body mo katulad ng live attenuated. So, ang maganda dito, mas madaling ma-transport and no risk of severe active infection kasi patay ng pathogen. Okay? So, ito yung sa Sinopharm. Example ito yung Sinopharm, yung isang vaccine na hindi yata na-approve sa atin. Pero ginagamit yung killed or yung pathogen na pinatay. So, ang effect nito ay mas mababa yung efficacy kasi weaker immunity ito. Kasi, kumbaga dead na yung pathogens, hindi na siya nagpo-produce, hindi na siya nag-reproduce sa loob. So, kailangan mo ng maraming doses, paulit-ulit na booster shots. So, yan sa cholera, hepatitis A, influenza, plague, and rabies. Okay. Okay, subunit. So, ginagamit mo na yung protein. So, yung mismong protein na nasa spike halimbawa ng virus. So, yun ang in-introduce mo sa body. Okay? So, this is yung immunogenic antigens. So, yung protein na yun, magpo-produce siya ng mga antibodies pa rin. So, advantages niya, lower risk of side effects, limited longevity, and you need multiple doses for that. And you have no protection against variation, diba? So, nag-mutate. So, ang virus nag-mutate, so pwede mag-change. And there you have toxoid, so it's an inactivated bacterial toxin. So, this only applies to bacteria. So, yung mga counteract yung mga toxins na nakaka-damage or nakaka-cause ng illness. So, this produces humoral immunity, so na-activating B cells to neutralize the toxin, but it does not prevent infection. Okay, so toxins lang yung tinatarget niya. And then you have conjugate. Ito naman yung capsule polysaccharide conjugate to the protein. So, dito, yung advantages dito, nagpo-produce ka ng T-dependent response to the capsule and you have better response in young children. But here, it is costly to produce and no protection against the antigenic variation. And this may interfere with other vaccines as well. Okay. So, and sa COVID, ito yung mga different na, syempre hindi pa na-produce yung RNA type, no? Pero basically parang subunit yun. Ang ginagawa ng RNA vaccine or DNA vaccine, ginagawa mo yung protein spikes or basically yung subunit using the structure, using the cell's function. No? So pagpasok ng RNA sa cell, gagamitin yung ribosomes para mag-produce ng proteins. And yung proteins na to, ito yung mag-produce ng antibodies. Okay? So yun yung DNA and RNA. So you have instructions for the body to make the antigen itself. So minsan dinadagdagan ng adjuvants. Ito yung mga molecules na kasama ng vaccine to help create greater immune response. Okay, so iba sa mga adjuvants na to, controversial sa mga anti-vaxxers. So, basically, we trust the experts, no? So, mga anti-vaxxers naman feeling experts sila, hindi naman nila alam kung anong pinagsasabi nila. Okay, and then yun nga, subunit, kung hindi to RNA produced kasi, kailangan mo ng doses, subsequent doses. Kasi pag RNA nag-produce, yung body mo mismo gagawa ng mga proteins na yun. So, active na gumagawa ng katawan. Itong subunit, pag inject mo, magpo-produce ka ng antibodies, but for that concentration ng subunits lang. Okay? So, medyo limited yung effect nito sa immunity. And then yung inactivated niya, as mentioned, so dead na yun. Yung Sinopharm, example yan, you need a lot of booster shots for that. Itong live attenuated, so example nito yung sa AstraZeneca, ginamit nila yung cold virus ng chimpanzee, tapos ginamit niya yung spike protein ng COVID para mag-produce ng immune response. Okay, so last topic natin. So, nagkakos ba ng side effects ng vaccine? May chance ba na pwede ka magkasakit even though vaccinated ka? So, yes. No? So, anyway, explain ko lang tong antibody-dependent enhancement and vaccine. So, immune responses to pathogens involve many cells and proteins. So, alam na natin ito, pinag-usapan natin non-specific at saka yung innate at saka yung adaptive or acquired. Okay, so you already know that. However, no, not all antibody responses are created equal. May rare cases, may antibody mo do not prevent cell entry. So, di ba, nakasabit yan sa spike mo. So, on rare occasions, they may actually increase the ability of the virus to enter cells. Okay? So, imbis na tumulong, hindi kumabit sa cell, tutulungan niyang kumabit yung virus dun sa cell. No? So, ito ay makakos ng worsening ng disease. So, this is called the antibody-dependent enhancement. Okay, so it is generated during an immune response recognition, during the time your immune system will respond, and they recognize and bind to the pathogen, but they are unable to prevent infection. So para siyang Trojan horse. Okay, so imbis na makatulong, mas mabilis pa yung infection. And it will exacerbate the immune response. Okay? Pero clarify natin, no? Not all vaccinated persons who get sick is automatically may ADE, no? So, let's talk about the 3 cases. So, una-una, may mga vaccines na magkakos talaga ng mild illness, nakakasakit ka. So, common to sa influenza vaccine. And yung sa COVID-19 din, di ba, sa Moderna or AstraZeneca, nagkakos siya ng mild illness sa mga tao. Okay? So, hindi siya associated dun sa disease. It is just your immune system responding. Okay? So, di ba, yung fever caused by yung feeling ng body na na-attack siya. Kaya nag-increase yung temperature mo. Pero, it's just proof na nagpa-function yung immune system mo. So, when 3 days, 1 to 3 days, wala na. Okay na yun. Another scenario na pwede kang magkasakit ay yung vaccine mo ay hindi effective. Diba? So, pinag-usapan natin efficacy. So, pag sinabing 50% efficacy, 50 out of 100 people will develop immunity. So, the other 50 will not. So pag sinabi ng 90% efficacy, 90 people be in, will develop immunity to the disease, pero 10 will get sick. So basically, yun yung mga nagkasakit, yun yung mga breakthrough. Okay? So in this case, the vaccine may not have worked at all, or it did not induce high enough levels of immunity to effectively stop an infection. And last, yung ADE. So dito, imbis na nakatulong yung vaccine, it will actually help the virus infect a greater number of cells than it would have on its own. Okay? So katulad na sinabi ko, parang Trojan horse. So they bind to the virus and help it more easily to get into cells than it would have on its own. So the result is often more severe illness than if the person has been unvaccinated. So sa COVID-19, hindi yan na, there's no scientific proof na may ADE sa mga vaccines na ginawa sa COVID-19. Pero sa sa Dengvaxia, proven na yan. Kaya nga yung Sanofi, na binago nila yung product label nila eh. Kasi previously, ginamit natin sa mass vaccination, wala silang warning. Lahat na vaccinate, no? But it turns out, there are two classes of people, no? So may yung tinatawag na seronegative at seropositive. Pag seronegative, never ka pang nakagat ng dengue. Pag seropositive, nagkaroon ka na ng antibodies or kinagat ka na ng dengue, mosquito na carrying dengue virus. So, that means, yung mga seropositive kasi, explain ko na lang yung studies, no? Yung sa studies kasi nila, akala ng Sanofi, mataas kasi yung serious or yung hospitalization ng mga may dengue sa mga 9 years old and below. So, inisip nila, wag natin ibigay sa mga bata, 9 years old below. Pero it turns out, sabi ng isang scientist, si Dr. Halstead, sabi niya, hindi naman dahil sa age yan eh. Dahil yung mga below 9, hindi pa yan nakakagat ng mosquito-carrying dengue. So, wala pa silang antibodies. So, ang nangyari, kasi ang dengue, simplify ko na lang, ang dengue, pag nakagat ka ng una, hindi ka usually makasakit. So, first infection yun. Hindi ka malubhang sakit. Hindi magiging severe dengue yun. Yung pangalawa, yun yung pwedeng maging deadly. Okay? Yun yung pinakadelikado. Pag makagat ka, kasi yung dengue virus nga, yung four types. So, explain naman yun ng reporter, di ba? Anyway, so pag nakagat ka ng pangalawa, yun yung may chances ng severe infection. So, para dun sa mga hindi pa nagka-dengue, once na magkaroon ng Dengvaxia sila, yun yung unang infection nila kumbaga. Okay? So, once na kinagat sila ng lamok na may dengue, chances na severe dengue mangyayari sa kanila. Mataas yung chances. Kaya maraming na hospitalized sa mga seronegative. Unlike kung halimbawa ikaw ay seropositive, kumbaga nakagat ka na ng dengue carrying mosquito carrying dengue. So, ang mangyayari sa'yo, first infection mo, okay, survive ka. Tapos pag in-inject ka ng Dengvaxia, yun yung second infection mo, okay na yun. Yun yung worst possible since ano na siya, controlled siya, hindi ka magkakaroon ng severe disease. At saka yung efficacy ng Dengvaxia, 60%. Ibig sabihin, sa 10 people, may mga 4 people yung hindi mag-respond positively dun sa vaccine. Okay? So, Yun. So, yun basically, pag second infection, no, mag-trigger ka ng second response na magiging mas deadly ang second infection. Kaya mas helpful yung vaccine for those who are seropositive or may antibodies na for that disease. So, ibig sabihin, kailangan yung magpa-test. Yung sa Sanofi, para gumamit ng Dayvaxia, you have to have your blood tested kung mayroong antibodies na bago ka ma-inject. Otherwise, yun nga, it may cause antibody dependent enhancement. Okay?